So today will be our review and summary section for what we have learned for these whole semesters. And I hope that these sections can lower your burden when you are preparing for the final exam. But before we start, I would like to share these verses in the Philippines chapter 4, verses 4 to 7 to you. So when I'm praying for you, especially when we are in this transition, moving all the classes online, I know this is not an easy task for a lot of us. So I know some of you also going to graduate in these summers. So when I'm praying for everyone, I hope that these verses from the Bible can comfort you and know you how to follow the guidance of God, even during this kind of the special situation during the pandemic. Rejoice in the Lord always. Again, I will say, rejoice. Let your reasonableness be known to everyone. The Lord is at hand. Do not be anxious about anything, but in everything by prayer and supplication with thanksgiving, let your requests be made known to God, and the peace to God, which surpasses all understanding, will guard your hearts and your minds in Christ Jesus. This is the word of God. And I hope that no matter you're applying for a job or apply a school in the future in the summer, don't be anxious about anything, but just put your prayer and needs in front of God with thanksgiving and believe that God will fulfill your needs. And let's try to focus on God, especially in this pandemic. So let's try to review what we have learned in these semesters. So this is a format you are going to see that I'm going to summarize the important fact, sentence by sentence. So let's start from the chapter 19. So we know that there are some particles carry the charge, and the fundamental unit is 1 electron charge, which is 1.6 multiplied by 10 to negative 19 coulombs. So this is the SI unit for the charge. And we know that there are two signs of the charge, negative and positive. And the charge is conserved in all the process. So they will either stay at this system or leave in this system, but always go to the other system. So which means you can never create or destroy a charge. And all the charges are in the fundamental unit E. So actually the charge is quantized. And also we have learned that if the two particles carry the charges, they will have the force in between. But since there are two different signs of the charge, so which means the force also have two different kind of direction, either repulsive or attractive. So we have learned that the same charge do not like each other, opposite sign of the charge attract each other. So this force is the so-called Coulomb's force and can be summarized in terms of this format. And the K is a constant. And here it is not mentioned, but force for the Coulomb's force is a vectors. So when you try to sum the force among the different kind of charge distributions, remember you have to add them like vectors. So this is what we have learned in the chapter 2 in the previous semester. So do you remember that I say that the vectors is the most important things. So if you are still not feel comfortable with using the vectors and doing the vector in terms of component form, this is definitely the thing you should focus on. And also we have studied that when the charge is distributed on some surface, for example, on the surface, then what is the surface charge? Then this electric force is related to the concept of electric field. So what is the electric field? It is the electric force per unit charge. So now we can define the electric field. So you can see there's only one charge. So this charge will produce a field called the electric field. So once again, electric field is a vectors. So when you try to sum all the contribution, please sum them like the vectors. Then we introduce you the concept of electric field lines. What is the purpose for the electric field lines? They will help us to visualize the electric field. And here is a very important thing about the convention of the direction of electric field lines. They always start from the positive charge and at the negative charge. Okay? So the denser the electric field lines, the bigger, the greater the electric field, the magnitude it will be. So actually from the field lines, you can know the magnitude from the density, and also from the direction from the positive to the negative sign of the charge, you know the direction of the electric field. And then when we try to introduce some special instrument produce an electric field, the parallel capacitors are the most important thing. What are the two parallel capacitors? Intrinsically, they are the two oppositely charged conducting plate. So on one side it is positive, and on the other side it is negative. So in that case, they will produce the electric field from positive end to the negative end. And also, when we study about the distribution of the charge on the conductors, we know that all the charge will stay on the surface because they don't like each other. So which means there's no charge within the conductors. So we have a conclude using the Gauss's law, saying that the electric field within the conductor is zero if the charge are static. That is very important concept. And now I just mentioned about the Gauss's law. This is one of the most important concept in chapter 19. So they teach you that actually the flux produced by the electric field can be related to the charge enclosed. So what is a flux? This is the electric field passing through some cross-section area, but there is a direction in between. So the flux produced by the electric field is the E times A times cosine theta. And what the Gauss's law tells you is that now this flux can simply be calculated in terms of the charge Q enclosed, very important, enclosed by the cross-section area. And this epsilon naught is simply just a constant. And you can see that from the epsilon naught here, the zero here, it is for the vacuum, the property in the vacuum. So this is a very important result. Now let's go to the chapter 20. So the electric force is just one of the force. And we have learned that if the force is a conservative force, then you can define a potential energy related to that. So here we also define what is the electric potential energy and also what is electric potential. So now we can relate the electric field we just defined to the electric potential, and this is also very important in these chapters. So electric potential is a scatter, but electric field is a vector. So therefore, the direction information of the electric field is determined by which directions of the displacement. So this is very, very crucial point. And don't forget about the negative sign. Okay. But because it is conservative force, so the total energy is always conserved. This is the thing we have learned before. And we also know that the positive charge will accelerate in the direction of the decreasing potential. So let me emphasize what do I mean by that. So if you consider using the capacitor as an example, the capacitor have one end with a positive charge, the other end is a negative charge. So the electric potential is higher at the positive end and lower at negative end. So this is a direction of the decreasing electric potential. And for the positive charge, because they don't like the positive sign, so they will be repelled by the positive plate. So they will moving in the direction of the decreasing potential energy. But people sometimes will get confused is that now for the negative charge, they are moving in the direction of an increasing potential energy. But intrinsically, it is due to the sign of the charge. And now, if you have the point charge, the electric potential is V equal to KQ divided by R. So since this is an open book exam, so the most important thing is that you can either make an equation sheet or you have to know that where to find the formula in the textbook. This is the most important thing. You have to know which equation to use when you're solving the problem. And the electric potential energy for the 2-point charge are this one. So you know that now it looks very similar to the electric field, but it is different one. And they are all scattered. So then we define the so-called equal potential surface. So what are the equal potential surface? Which is the path. If you are walking along that path, the electric potential difference is 0. And also, the electric field is perpendicular to the equal potential surface. So therefore, the surface of the conductors is an equal potential surface. And now let's try to go back to the two parallel plate. So the two parallel plate is actually a capacitor. And they are a very important instrument in this chapter 20. So first we define a quantity called a capacitance, which is for these two parallel plates, the charge accumulate divided by the voltage difference. This is the capacitance of the capacitor. So for the parallel plate, I have to show you that you can use the Gauss's law, then you can derive that the capacitance for the parallel plate only is this formula. So this is the definition. This is true for all the devices can create a capacitance. But for the parallel plate, this is the value. And when you start in the capacitor, the very important thing is that usually we assume in the two parallel plate, it is vacuum, it is empty. But when you put the dielectric material inside that, then the polarization of the dielectric material will affect the capacitance and the electric field inside that. This is a very important thing. Okay, and the trick I teach you is that every time when you see epsilon naught, you just multiply it by the dielectric constant by the epsilon naught. When it appears here, you multiply it by the dielectric constant. And the capacitor is a device can store the energy, and this is also one of the very important things. So the energy stored in the device can be expressed in terms of the electric potential energy stored in the device, and this is the expression of that. And the energy density is that now you have this amount of the electric potential stored in the volume V. So you may ask, what is the volume V? Use the parallel plate once again. So there's a volume occupied by the two parallel plate. Yeah? So you just divided that, this U divided by the volume. That is a concept of the energy density. And now let's go to the chapter 21. Then we start to study about the circuit. But before that, you have to define the quantity called the electric current. What is the electric current? The flow of the charge. The SI unit is ampere. So now, if you know the direction of the current, which is the direction of the positive charge, then you can start to build a circuit. And we know that the second important component in the circuit is the resistor. So R is the resistance carried by the resistor. And this resistance depends on the length of the wire, the cross-section area, and also the resistivity, which is an intrinsic property carried by the wire. So this is very important formula. So now we can introduce you that when you study the circuit problem, Ohm's law is very important. V is equal to I times R. And for sure, when the current is moving from higher energy potential, electric potential, to the lower electric potential, they carry the energy. So energy will be dissipated in the resistors, and this is the power given away across a voltage drop. So if there's a current passing through the resistor and there's a voltage drop, then this is the power given away. So if you try to apply the Ohm's law, you will see another formulas. And this is the unit you're going to see in your electric bills frequently. And now when you build a circuit, this is actually one of the most important concepts in the chapter 21. If you have the resistor in series, this is the formula. But if you have the resistor in parallel, so how did you study that the resistors are in series? Which means the current passing through R1, R2, R3 are the same. How did you know that the resistors are in parallel? Then the voltage across R1, R2, R3 are the same. That is very important. Then the second important thing is that the Kirchhoff's rule, the junction rule, the conservation of the charge, the loop law, which is the conservation of the energy. Then we study about the capacitor in parallel and in series, and you'll find out this is in the totally opposite order compared with the resistor. So don't forget about the difference of that. Okay, so when you study the capacitor in parallel, which means the charge on across C1, C2 are different, but the voltage is the same. But in series circuit, the voltage across C1, C2 is different, but the charge across C1, C2, C3 are the same.